Welcome to Physics Solution Center. Today, I want to take us through Cathode Ray Oscilloscope. This is an important instrument in electronics. While I was in the university, I used this electronics especially during circuit construction. I noticed that most A-level students find it difficult to interpret this signal because in some schools they don't even show them the instruments. They only ask them questions because they don't see it. They only ask questions from it. They find it difficult to answer it. So today I want to briefly show us a few things around it and show us pattern of questions, how they set the question. An oscilloscope is a test instrument that enables us to look at the shape of electrical signal or pulse by displaying time of signal. The key word there is time of signal. We use it to find the time period and use that to find the frequency. Let's look at some shapes. The first shape I want you to take note is sinusoidal wave signal. This is the shape that is regular in terms of waves. It's important for you to know that the x-axis of CRO is the time period, while the y-axis mostly is for voltage. If you are asked to find the peak voltage, that will be the amplitude. If you are asked to find the period it takes for it, you go for a complete cycle. Remember that period is the time taken for a wave to complete a cycle. The horizontal axis, we call it time base. It determines the kind of signal you use. And when you know the time base, you use that to find the period, then you use that to find the frequency. I'm going to show you how they connect so that you can do it yourself. Let's look at the first one now. For time period, what we do is we identify a complete cycle. When you identify a complete cycle, you count the number of boxes that form that complete cycle and multiply by the time-based setting. At the extreme end, you will see the dimension given. For instance, this one, they show us that each box is a square box 1 centimeter by 1 centimeter, meaning if I have 4 boxes, it means that it will be 4 centimeter. The formula that we use to find the period will be length for a complete cycle times the time-based setting. Length of a complete cycle times the time-based setting. Now, if in a situation we don't know the total length for a complete cycle, we can use the total length of the whole graph and divide it by the number of cycles to get our length for one. Let's look at an example from past question. This is a past question 9702 paper 1 May June 2006 is an old paper in which they have started repeating some of these questions. The question says a cathode ray oscilloscope display shows the waveform produced by an electronic circuit. The CRO time base is set at the division. This is another thing to draw your attention to. Some students will look at ms, they say 10 meter second, which is not true. That is 10 milliseconds. The question is, what is the period of the signal shown? You will find what gives you a complete cycle. In this question, we have 1, 2, 3, 4 boxes. The period t will be equal to number of boxes times the time-based setting. In this case, we have 4 boxes times 10 milliseconds per division. This will give us 40 milliseconds. This is the period t. The answer is C. You can see how simple the question is. It's only simple when you know what you are doing. The next one is a square wave. Square wave, you can see, is not like the sinusoidal. This one is a square shape. For you to identify a period for a square, you will pick where you start and where it ends. If I pick this point, I notice that it's starting another one here, that is a complete cycle. This will give me the period. If I'm picking at this point, I'm going to check another place that is like that, which is here. I will count the number of boxes that form that period. 1, 2, 3, 4, 5, 6. Those are the number of boxes. I will check the dimension given to me. With that, I will get my period. Let's look at an example. This is a question, past question 2012 October November, paper 1-3. A cathode ray oscilloscope displays a square wave as shown in the diagram. The time-based setting is 0.2 milliseconds per division. What is the frequency of the square wave? In this question, we are asked for the frequency. We will first find the period, then use it for frequency. How many boxes form this? We have 1, 2, 3, 4, 5, 6. So we have 6 division times the time-based setting, 0.2 milliseconds per division, give us the period. This will be 1.2 milliseconds. We now find frequency. Frequency equal to 1 over t. That will give us 1 over 1.2 times 10 raised to the power of minus 3. You must change your milliseconds to seconds so that you can do it well. Put it in your calculator. This will give you 830H. You can see this, how to go about it. If you don't do that, you will miss it. Change milliseconds to seconds before you use it. Let's look at another shape. This shape is pulse signals, like heartbeats. In this shape, this is the beats. This is the pulse interval before the next beat. You are to pick this as your period. Take note, sometimes students don't know how to identify it. That is why I'm forming this video for you. The time period for one complete pulse times the time-based setting will give you. In this case, you can see this is like 2 boxes to form the time, the period. So let's look at an example. This is an example of such question. We have the diagram shows 2 pulses on the screen of a cathode ray oscilloscope. A grid of 1 cm square covers the screen. The time-based setting is 1 microsecond. In this case, this is microsecond per centimeter. This will give is how long does each pulse last? How long? We have period equal to the number of boxes times the time-based setting. This will give us 2 times 1 microsecond per cm, which is 2 microseconds. You can see the question look very simple because they know that sometimes students don't even know how to go about it.